Its distance between 2 points in a 2D plane. Till now, we have seen the distance between 2 points if they are either on the axis or between any 2 points that are parallel to any one of the axes. For example, CD is equal to 7 units minus 3 units is equal to 4 units. Whereas C and D, it lies on the x-axis. If you can see very well, this is C and this is D. So the D is 7 units from the x-axis. C is 4 units from the x-axis. So the difference between the two gives the length of the line CD. Now, how to find the distance between the points A and B? This is a line segment which is parallel to the x-axis. So just find the difference between the x coordinates of the points, which gives the length of the line segment as 5 units. Now, these are lines which are parallel to the any one of the axis or it lies on the axis. Now, how do we find the length of any line segment which is not parallel but it forms part of a, if you look into the second graph, it forms part of a triangle. So, we need to find the length of AD. How do you find the length of AD? You need to drop a perpendicular to the point C and construct a right angled triangle at the point C so that we are able to find the length of AD by using Baudhayana Pythagoras theorem. According to that theorem, AD squared is nothing but AC squared is equal to CD squared. The square of the hypotenuse, see this is the hypotenuse, the square of this is equal to the sum of the squares of the other two sides. Which are the other two sides? AC and CD are the other two sides. Now the square of the other two sides and the sum of it gives the length of AD. This is one side of the triangle AMD. So, how do you find the length AC now? It is the distance between the y coordinates of the points A and point C. We can infer from the graph very well. Or how far the point A has traversed from point C along the y-axis gives the, see this is the y-axis parallel, this is a line segment parallel to the y-axis. So the distance of the y coordinates of the points A and C gives the length AC. Similarly, we can find CD, which is nothing but the distance between the x coordinates of the points C and D. Now, or how far the point D has traversed from point C. This is the length of the line segment CD. So, AD is nothing but square root of AC squared plus CD squared. Find out the coordinates of C. It happens to be 3, 1. So AD is nothing but do the evaluations as mentioned over here and you get the length of AD as 5 units. The similar construct we can use to find the length of DM. What is DM? This is DM and this is AM. So by similar usage of the Pythagoras theorem, we can find out the length of these line segments. In this slide, let's understand how the reflection has an impact on the length of the sides of the triangles. As you can see from the figure 1.9, the first triangle is in quadrant 1 and the other triangle is in quadrant 2. The triangle in quadrant 2 is nothing but a mirror image of the triangle in quadrant 1. It makes no difference whether x2 minus x1 and y2 minus y1 are positive or negative, as we are simply measuring the shifts along the two axes. We are just going to identify the lengths of the 2 points along the axis. So it makes no difference whether it is in quadrant 1 or quadrant 2 or 3 or 4, as it is just the shift. So C dash D dash is nothing but x coordinate of C dash minus x coordinate of D dash, which is equal to 4. A dash C dash is nothing but the difference between the y coordinate of A dash and the y coordinate of D dash, which is equal to 3. Using the Baudrillard-Pythagoras theorem, we get A dash D dash as 5 units. Similarly, we can calculate both D dash M dash and M dash A dash. What we need to understand is since it is a mirror reflection of the triangle from quadrant 1 on to quadrant 2, the distance between the sides or the distance between the points of the triangle remains the same whether it is in quadrant 1 or quadrant 2 or any other quadrant.